We are asked to evaluate the line integral over c of y dx plus x cubed dy, where c is an arc of the parabola y equals x squared minus x minus 2, traced from the point minus 2, 4 to the point 2, 0. Step 1. Since the curve is already given as y in terms of x, we parameterize using x equals t. This means t will range from minus 2 up to 2, matching our start and end points. Step 2. Substitute the parabola equation to express y in terms of t as well. Since y equals x squared minus x minus 2, we get y equals t squared minus t minus 2. Step 3. Find dx by dt and dy by dt separately. Differentiating x equals t gives dx by dt equals 1. Differentiating y equals t squared minus t minus 2 gives dy by dt equals 2t minus 1. Step 4. Build the full integrand. We need p times dx by dt plus q times dy by dt, all times dt, where p equals y and q equals x cubed. Here, p equals t squared minus t minus 2 and q equals t cubed since x equals t. So the integrand becomes the quantity t squared minus t minus 2 times 1 plus the quantity t cubed times the quantity 2t minus 1 all times dt. Step 5. Expand and simplify the algebra fully before integrating. The first part stays as t squared minus t minus 2. The second part, t cubed times, open bracket, 2t minus 1, close bracket, expands to 2t to the fourth minus t cubed. Adding these together gives 2t to the fourth minus t cubed plus t squared minus t minus 2. So our line integral becomes the integral from minus 2 to 2 of the quantity 2t to the fourth minus t cubed plus t squared minus t minus 2 dt. Step 6. Integrate term by term. Integral of 2t to the fourth is 2/5 t to the fifth. Integral of minus t cubed is minus 1/4 t to the fourth. Integral of t squared is 1/3 t cubed. Integral of minus t is minus 1/2 t squared. And integral of minus 2 is minus 2t. So we get the antiderivative 2/5 t to the fifth minus 1/4 t to the fourth plus 1/3 t cubed minus 1/2 t squared minus 2t, evaluated from minus 2 to 2. Step 7. Plug in the upper limit, t equals 2. That gives 2/5 times 32 minus 1/4 times 16 plus 1/3 times 8 minus 1/2 times 4 minus 2 times 2, which works out to 64/5 minus 4 plus 8/3 minus 2 minus 4. Combining these over a common denominator of 15 gives 82/15. Now plug in the lower limit, t equals minus 2. That gives 2/5 times minus 32 minus 1/4 times 16 plus 1/3 times minus 8 minus 1/2 times 4 minus 2 times minus 2, which works out to minus 64/5 minus 4 minus 8/3 minus 2 plus 4. Combining these over a common denominator of 15 gives minus 262/15. Subtracting, we take the value at t equals 2 minus the value at t equals minus 2, that is 82/15 minus, open bracket, minus 262/15, close bracket. Notice the double negative here turns into addition, so this becomes 82/15 plus 262/15. Adding these together gives 344/15. So the final answer is the integral over c of y dx plus x cubed dy equals 344/15.